Two observers, same event, different time. One sees it begin, the other sees it already over, because near this object, time does not agree. Space looks empty, silent, still, endless, but signals repeat, stars collapse, planets burn. Some things out there should not exist. This is space horrors, the universe that should not exist. Time feels universal. 1 second here, 1 second there. One event happening once, but that is not how the universe works near extreme gravity. Two observers can watch the same event and not agree on its timing. Not because one is confused, not because the clock is broken, but because time itself is measured differently from different places. Near a black hole, gravity curves space-time so strongly that light, motion, and duration stop matching ordinary expectation. The event still happens. Physics still holds. But the observer loses the simple version of time. General relativity does not treat time as separate from space. It joins them into space-time, a single structure that mass can curve. The stronger the gravitational field, and the more extreme that curvature becomes, and where gravity is stronger, clocks can run differently compared with clocks farther away. This is gravitational time dilation. It is tiny near Earth, measurable with highly precise clocks, and essential for modern navigation systems. But near a compact object, the effect can become enormous. A distant observer may measure time, while someone deeper in the gravitational field measures another. Time is not failing, it is local. The event horizon is often described as a point of no return. But from far away, it also becomes a problem of observation. Imagine matter falling toward the edge of a black hole. Locally, near the falling matter, time continues forward. The fall does not feel frozen. But to a distant observer, signals from that matter become stretched, dimmed, and delayed. The closer the matter appears to the horizon, the harder it becomes to see it complete the crossing. This is where intuition breaks down. The object does not stop existing. The laws do not stop working. But the outside view becomes trapped in delay. This is a silent introduction. Time is not the only thing distorted by gravity. Light is affected too. The gravity is immense. A black hole does not need to shine to reveal itself. Its gravity bends light from whatever lies behind it. A star field can warp. The space itself ripples. A disk can appear doubled, and background objects can smear into arcs. This is gravitational lensing, a massive cosmic effect. It turns gravity into optics, mass into a lens, space-time into glass. But the lens is not simple. Some light takes a shorter path, a different route through space. Some takes a longer path through the distorted fabric of space-time. Some bends around the mass more than once. The same source can arrive as different versions of itself. When light is bent by a massive object, it can split into multiple paths. Each path carries information from the same source, but each path may take a different amount of time to reach us. That means a single event can appear more than once. A distant supernova can be seen in one image, then appear again in another location because its light took a longer route through curved spacetime. To us, it looks like repetition, or delay, or a cosmic echo, but nothing is replaying the event. The universe is delivering different light paths from the same explosion at different times. One event, multiple arrivals. This is where the story becomes stranger. We often think of the universe as a timeline, events lined up in clean order. First, then next, then after. But when gravity changes the path of light, the order we observe can stop matching the order we expect. An event that already happened can appear new. A later image can show an earlier stage. A delayed path can make the past arrive after the present. The event itself has not changed. The physical sequence remains real. But the observer receives the universe through distorted routes. Perception is relative to the observer's path. Near a black hole, space becomes a distorted mirror, not because it reflects light like glass, but because it redirects light. The accretion disk can appear above and below the black hole at the same time. The far side can be lifted into view. The background can bend around the shadow. What looks impossible is actually geometry. The eye expects straight lines, one image, but gravity gives it curved routes. Space-time can deliver more than one image. This is the horror of extreme gravity. It does not break reality, it breaks the view. The most frightening part is not that the universe becomes lawless. It does not. The rules remain. The mathematics holds. The light follows paths through curved spacetime. But human perception was not built for this scale. We were built for straight horizons, slow gravity, and time that feels shared. Near black holes and dense objects, those assumptions fail. One observer sees delay. Another measures passage. Light arrives more than once, and the same event refuses to stay simple. Reality does not break. Our version of reality does. Nothing in the universe truly stops. Stars collapse, planets burn, signals continue through the dark. Creation and destruction happen constantly, and the universe continues, whether humans understand it or not. The universe does not need monsters. It has gravity, radiation, pressure, vacuum, and somewhere beyond what we can see, the next anomaly is already moving. This is space horrors, the universe that should not exist.